Okay, so let's start. So morning, everyone. Today we are focused on the machine vision solution from Delta. So, uh, okay, as usual, during the introduction, please raise your hand if you have some question. And also, you can put the question to the Q&A portion and type in your question, and then we will answer as soon as possible. So for today, for webinar, we will learn three things. First one about the product from Delta about the machine vision. The second one is the successful case sharing from our product. And also I will demonstrate to you how to quick start from our product. Okay, and this is the Delta family. So today we focus on the machine vision system here. Okay, so here's the outline. We go into the first portion, the embedded vision controller, DMV Series. And here's the whole family from Delta about the machine vision. So as you can see for the first generation, the blue one, the 1, 2, 3 generation is the embedded system. That means all the controllers integrate everything. User just need to use this controller linking with their display, and then can do the configuration, checking or everything inside the controller. So for the first generation, it's the basic one. The model name is DMV1000. So so the picture is first is IEEE 191394. This is the protocol, and we support 2 cameras, but only the normal, no colors. And the resolution is not so high; it's only 0.3 and 0.8 to type. So the purpose is more focused on the positioning, the guidance, and we do support a lot of communication interface like RS-485 and Ethernet. And for the connection, we support the VGA to show the display, and also we have the input and output. Here you can see from the terminal. And also we support SD card, so that you can save your image and save your data into it. And for this one, we controlled by the joint board. Maybe like play a game. It's a very easy one to let you configuration and do some parameter settings. And for the second generation, the advanced type is the DMV2000. So first, this is the camera link protocol, and we support four set camera. It's the color or normal, both support. And for the camera resolution, we start from 0.3 to 2 megapixel, 4, 5 until 12 megapixels. And others think as 1000, but also we support the HDMI. And also this one controlled by the mouse, by mouse control. And then we go to the third generation, which is the DMV 3000. I think this one we update end of last year, and this is the we call this one is the standard type DMV 3000. So you can see the difference is first one is support the GigE camera to set color or mono both support. And for the resolution, right now we have 2 set 0.3 and 2 megapixels. And in the second half of this year, we will have the 5 megapixel cameras. And also this one support the mouse control, and also we support the wireless type. So and the next one is I call this one a PC-based solution. Actually, it's the software license. We call it DIA Vision. So Basically, for the cameras, it supports maximum channels, 6 channels, no matter the color or the normals. And for the functions, it's more focused on the auto calibration. We support the robot. Right now it's from Delta, Gibson, Yamaha, and ABBs. Auto calibration means we already integrate the system. So for users, if your application is collaborate with a robot, we will very just like a quick setting to finish this part, and then you can focus on the next step. And also we support the inspection and identification functions for this one. So today I will focus on the new product, the third generation DMV3000 and DIA Vision. Focus on these two parts. I guess so far my voice is okay, so I will continue. This is the specification comparison for your reference. So as you can see, the different first one is the resolution for DMV2000 with up to 12 megapixel, and for 3000 right now it's 2 megapixel. And then other things is the camera models, it's the IEEE and Camera Link and GigE. And others, I think others is almost the same. And the cycle time is the maximum fast speed we can reach. So you can see for DMV2000 we can reach the 15 microsecond, and for DMV3000 we can reach the 30 millisecond. And also the power consumption for DMV3000 is 2.5 ampere. It's okay because this one will continue run at the side. So let's focus on the DMV3000. First one is the hardware interface. So you can see first the size, I think it's very compact design. It's not too big and very light. It's only like 0.3 kilogram, very light. And for first one is the DC power supply, and we have the terminal for input, like the trigger signal, and also we have the output terminal, like to control the flash and others. And also for the communication, it's the RS-232 and RS-45, and also the Ethernet, mobile TCP, and also the other functions. And also for the camera, here we have 2 ports to support the GigE camera port, and also SD card, USB port, and also the display VGA port. So this is the whole picture for the hardware interface. And here's I highlight some picture from this table. So first, you can see some multi-tools. No matter it's the function type or no matter it's the pre-process type, we support many tools to fulfill the application requirement. And of course, the GigE camera, I think right now it's a trend. Most of the it's more and more welcome and popular for the machine vision applications. And also for the communication, we support the multiple types to fulfill the requirement. And for the data exchange, if you're linking with Delta PLC or robot, it's very quick, just like a quick mapping. So you no need to do the data mapping one by one by yourself. We have the fast data exchange function. And of course, it's very slim design. The size is very compact. And besides that, and I think compared to the last generation, DMV2000, if you ever use this one, you will find the DMV3000, the user interface is very friendly compared with the last version. Okay, here's some UI interface for your reference from DMV3000. So you can see first is on the top. I start from the left. First one is a project area that shows the currently project you are editing or running now. And next one is the display to you can enlarge or zoom in, zoom out. And next one is the system settings, communication, or some basic settings. And next one is the status to let you know some like OK or NG, and how about the cycle time. And the last one is a judgment to let you know it's OK or NG for this program. And for the big area, of course, it's the image area. It could be static, and also dynamic. And next one is a result area to let you know maybe it's the X, Y, Z coordinate, or some angles, or the how many, and how about the quantities, the result from your functions. And then we go to here is the workflow area. So like actually our configuration is like a guiding type. We guide you step by step to finish all the settings. So you just follow the workflow. Like the first one to set the camera, and also we have some function you can edit into the flow. And then if you need the I/O input and output, and also the value data output exchange. So basically, this is the workflow area. And once you finish all of that, I could see the program is already finished. And for the last one, you can see from here's the trigger. We have the manual trigger and the continue trigger. And here show you the currently it's a developing or runtime interface. We have the ID. Right now you can see it's the ID. And if you click and then switch to the run mode. Okay, so this is the user interface for your reference. And next one is the function. First one, we start from the pre-process. Pre-process means after you take the original picture, maybe it's not perfect, so you need to do some pre-process, like the dilations. And you can see this is the original one. And after you do the pre-process, by the name is dilation, and it will become more better than before. And if you're not satisfied, we have multiple ways to let you know to get you what you want. So basically, here's all the pre-process we support right now. Okay, and next one we go to the function tools. For function, we separate by the edge detect, and also the area detect. So for the edge detect, we support the function like the position, the width, the angles, or even we count like the IC chip. We need to count the pin quantities. And for the area, you can see I think the shape match is the most very popular function to position the target component. And also the area functions, intensities, blob, OCVs, verification, and also the barcode scanner function, even no matter it's a barcode or 1D or 2D code. So this is all the functions right now we support. And also besides I could say this is a standard function. And also we integrate some applications like robotics calibrations and some cup inspections. We also integrate this application function inside the software. Later on, I will show you the details. And next, we go to the typical application for DMV1000. So first one you can see is the quality inspection or gauge. Gauge means like a measurement. Uh, so, so you can see here, I list down some typical. First one is like a label inspections. You can see from the picture, here's some damage. So we can check the damage from the label. And next one is a size inspection for the component. No matter which age you want to measure, we can also fulfill that. And also it's the direction check. So maybe this is the production line, and maybe you can see they have the direction up or down. So we can also do this kind of checking. And also it's the next one is the quantity count function. So for example, this is the ball inside the ring. So we need to check the quantities of the ball in case of some ball is missing. And next, the application, we focus on the guidance and identifications. So you can see, first one, I think the guidance, the typical one is the pick and the place, collaborate with the robot. I think right now, many applications like this, we need to collaborate with even the SCARA robot or articulate robot. I think 80% of the robot, they are working with the vision system. So this is very important. And we do focus on this. We want to make this part more easy for the users. So that's why we developed the auto collaboration functions. And also the code read, no matter it's the barcode or QR code, we can also use that. And also we support the OCR and OCV functions reference. Okay, next is the Delta camera. So you may have a question why I introduced this one. So first, I would like to know this camera actually is the manufacturing design and manufacturing from Delta, our own self. It's not like the OEM from the others. Actually, we do manufacturing this product from our own self. And right now, we have two types. You can see the main differences about the resolution. This one is 0.3 megapixels. We have two type, color and metal, mono, and this is some in like a frame rate, and the optical size for your reference. And the size is, I think the size is very small, very compact design. And next one is a 2 megapixels, and this size, I think the size is similar as the first one. And this is currently the product right now we have. And in the future, we are planning to have more higher resolution, like 5 megapixel, 10 or even 12, and up to 20 megapixel in the future. And the type is GigE. We focus on the GigE type. The type is global or rolling. And of course, it's a PoE type. And also we provide the separate power supply. So it's a both type. Okay, this is all the DMV3000 production. And next one, I would like to share the PC solution from the DIA Vision. So, first of the things, the algorithm is actually all developed from Delta for the functions. So it focuses on the robotics, the guidance, and also the inspections and identify. So as I said before, we support the robot. Right now it's the Delta, Epson, Yamaha, and DB. And the alignment stage is 6, at most maximum is 6 cameras, and precision I think is very high. I think the main advantage for the PC-based solution compared with the embedded controller, the cycle time is be faster and faster because it's based on the PC. The performance will be higher than the embedded system. So I think this is the biggest advantage compared with and also of course the function will be more choice for the users. Okay, and the UI also is a very friendly UI, easy to start to reduce your learning loading, and also for the hardware normally it's working with the IPC, and it supports the GigE camera. So here's the DI Vision's architecture or structure. As you can see, here's the display, and then we link to the IPC, and then link to the GigE camera. And for the IPC, if there's a robot, we link to the robot controllers. So this is a Delta robot for your reference. And for the applications, right now we focus on the food and beverage, electronics, logistic, and packaging. And here's the user interface for your reference. Actually, we try to make it same thing as the embedded system to reduce your learning loading. So the main difference is just from the PC-based or embedded controllers, because at the I think for the end user, the hobby they used to different types, so it's a multiple choice for them. And also for the editoring is a flow. It's like a workflow type from the top to the bottom, and then you finish the program. So I could say it's friendly to the starter, to the users. And here's some functions for your reference. So first one is a robotic solution, guidance. You can see, I could say mostly it's a pick and place application from the production line, no matter what kind of the Delta, what kind of the robot, like a spider type, Delta type, or the Scara or articulate can fulfill that. So this is the first one. Okay, and here's the more applications for your reference. The conveyor type or pilot type. And this one is for the food and beverage to inspect, to check the wording from the package. So we use the shape functions. But the picture is if the package maybe there's a deformation, like you said, this is the normal one. It looks all good. But if there's some deformation, we still can detect the wording to check the locations. And next application is for the inspections. For inspection, we do the quality check. And focus on the defect parts or on the surface or the quantity or the direction, dimension, or even the print quality and data collection. Also, even we integrate some CPK calculation into the software, since this is a quality check. So here's some applications for your reference. Here's to check the bottoms, water bottoms of the level of the the surface. And this is, I think, the aluminum can to check the inner, where there's some damage or some dot. And also this one is some like a glass bottom to check no matter some damage inside the bubble inside. Because if for the glass, if there's some bubble inside, maybe it's just in the future there will be some crack from the bottom, so it could be dangerous. And also for the quality check, we do the PET blow machine check. This is the material from the bottom. You can see this is the end product, and before the blow machine, actually it looks like this. So so some customers, they also want to check this material before put into the blow machine. So we may check from the top. You can see this is the false one. There's some the system detects some damage or some crack from the surface, and this is also the false one. Okay, you can see the same. This is a PET checking. This is the past one. You can see it's all good. It's all good. And we use the lighting from the slide, the direction from the slide, and the multiple angles to highlight the area we want to detect. And also this is aluminum cans we checking. So you can see for the right side one is the OK part, and for the NG part, NG side we detect some area. And later on, for the demonstration, I will show you one case from the purple cup inspection paper. Paper cup. Okay, and since next one we're going to the successful case sharing, and for this part, I would like to share it by different industry. So let's see. First one, we start from electronics. So this one is the printed circuit PCB board. Actually, it's a PCB board positioning. Actually, the application is to the pick and place. So the environment like this is a conveyor, and the continuous moving the PCB board to the area of the detection. So the camera one will detect the roughly position and then send the command to the articulate robot to pick the PCB board. And next step, the robot will put the PCB board into some tray or some locations, but it has to be very precisely. The accuracy must be high. So there's another camera too to do the detail check and to do the positioning. The accuracy will be higher. So this is the whole application. So here's some configuration for the system. We could see the controller is a DMV1000, and the camera 1 and camera 2 is both 8. This model means the resolution is 0.8 megapixels. And for the lens, I think for this application, we select the same focal length, the 12 millimeter. And illumination, for the camera 1, we use the backlight from the back, from the bottom. And for the camera 2, we use the ring light, the white ring light at the front. And this is a working distance for the first one. Actually, it's about like 0.8 meter, pretty high. So actually, the object is it's a lot, but the accuracy may not so good. And for the second one, it's a working distance, only 90 millimeters. And this is a view of the view for your reference. So let's see the result. So these two pictures is from the DMV1000. So you can see this is the camera one. Actually, it can detect many PCB port, and then we'll send the signal to the robot, and then the robot to the pig and move to the camera two. So you can see actually for the camera two, they can do the detailed checkings, and also the positioning, because the camera two is the position is fixed, right? So they will send the position to the robot again to let him know right now the offset, what is the offset. So after that, the robot will calculate by himself and then place the PCB into the right location. So this is the first one. For the second one is the semiconductors industry. So I select these applications, the OCV inspection for the laser. Actually, it's a laser machine. They will put some wording, some characters inside into the product. So the purpose, we have to check whether the word is correct or not. So we using the OCV functions. And so for the device configurations, you can see we use the ring light from the two sides, and there's some angles to light the object. And for this application, we select the DMV1000, and the lens is 1225 millimeters focal length. And illuminations, we use the white bar light. It's not the ring light, it's the bar light. Two parts, and the working distance and typo way for your reference. So let's see the result. So this is the result. After we put adjust the lighting, so it will highlight the target characters, and then the system we use the OCV functions and then send all the result to even the controllers or even to the upper system to let them do the quality checking. Next one is the machine tool, the CNC machine. So I selected this one. This is a screw. This is the materials. So the purpose is to check to measure the radius R, sharpening the radius R from the screws. So for this case, we select the 35 millimeters focal length, and the illumination we use the right parallel light, and let's see the result. Okay, so you can see this is the result after taking the pictures. We'll highlight the R dimensions. So the purpose after we do this one, and also we have to do some calculations for the inside the system to get the R radius measurement. Next one is in the automotive industry. This is an exhaust pipe. We have to do some inspections to check the qualities. So you can see for this application, we choose the two cameras. First one is use the bar light. To check the surface, and then the next one is we use a ring light. It's a red colors to check the inner portion. So let's see the result. So this the top two pictures actually I think from the camera two. Okay, check the inner. So we use the shape function and area function to make sure there's no part missing. And also we use another camera to check the surface, to check the wording, the correct or not. So this is this automotive. And next one is for the rubber and plastics application industries. And I choose the plastic bottle and the washer inspections. So you can see this some bottom, no matter it's a shampoo or cream. So we have to check there's maybe some quality issues. So we use the backlight, and in the middle is an object, and then we put the camera here. So let's see the result. Basically, it's a quality checking. So we have the golden sample is okay. So as you can see from the left, it's a okay part. So you can see we focus on check the cups, and then you can see this is another product. Obviously, the size is smaller than the standard one. So after we do the measurement, and then we find this one is a defect. So we have an NG signal inform the system. And this one we check the outer ring. So you can see this is the okay part, and for this one, of course, it's missing. So maybe something wrong about the flow molding. So the system will detect, and then there's NG signals, you know. I saw some people have some questions. Maybe after this section, I will give you some time to answer your questions. So next one is the packaging. For packaging, I selected this one is the inspection of the face mask outer packages to check maybe check some color, some shape, or some wordings correct or not. So because of the surface will reflect, so we choose the bar light, two sets of the bar light at the slash angles to reduce the reflections. So let's see the result. So for this case, actually we're checking the label. There's some wording. So you can see for the first one, this is the golden samples. And for the defect one, the part is missing. So we will inform the system and signals. And for this one, we check the barcode at the top of the level, and this one is missing, so we will know to inform the system. And this is another thing I want to focus that you know is for the paper cup to check. And also this one we integrate the function into the DMV1000. So the target checking is multiple is check the cup of the bottom, check the surface, and even check the top of the cup. It could be very easy to set up. Later I will demonstrate to you how to do this part. And others like printing or pharmaceuticals. For the pharmaceuticals, I have some videos for your reference. It's a tablet quality inspection. Okay, here's the video. Actually, you can see the tablet moving very fast, and here we have to set there's a defect signal from the system reject product. So you can see all the defects there. Okay, so about the successful case sharing, do you have any questions? Let me see. Or if you have some questions, you could raise your hand and let me know. I saw one question is, do you provide the light source as standard accessories from the vision? Yes, WJ Kang, we do have the accessories about the light source, but I could see it's a very basic type, like the ring type and some bar type, but not so many. So the answer is yes, we do have, but not so many types. And another question from Tina Chai. Now the DMV3000 cameras is a global or ruling shutter. I thought could you type on the line? Help me to check because I forgot about this part. Tina Chai, maybe I will answer your question later. Another one is how should we choose the camera? Is there any standard to follow? For example, size of the object. WG Kang, I think this is very important for the model selections. So basically for the cameras, the only matter is the resolution. So if your project, the focus is inspections, so the details must to be very important. So in this case, I could suggest the resolution, the higher is the better one. But if your applications is like a positioning and maybe the object moving very fast, so it requires the fast cycle time. Because it's a positioning, so the details may not so important. So in this case, I could suggest the camera, the resolution smaller is the better one. For example, like 0.3 megapixel or 2 megapixels to fulfill the requirement. And also another question is, can we install the DI vision into the Linux operating system? I think right now we only support the Windows, but I'm not sure. Maybe later on I will confirm to you again. Oh, okay. So let's go to the next part, the demonstration. So for the demonstration, I would like to focus on the DMV3000. So the first one is a quick start. Let you know 5 minutes to let you know the whole processing and whole configuration. And next one is a cup inspections, the paper cup inspection functions. We demonstrate the real case to let you know. And then last one is auto calibration with the Delta robot. So I would like to this one. And this is a site, a website to help you to learning the. Could you see the anyone? Could you see the videos? Please let me know if you cannot see the video because right now I'm playing the video. I guess I'll say so. Let me introduce. So this is the DMV1000. Wow, you mean my voice or the video? Okay, I cancel the computer voice. Oh, I think now it's better. So let's back to the applications. So we just start a new project, and then we check the component is okay or NG to the quality check. So here we put the okay sample here, and then we take a picture as a golden sample, and then we do some adjustment about the cameras, like the shutter speed. And then we select the functions. For this case, we use the shape function to target the component first. And then we go to the range of the intersection, the full screen, and then we select the target model to help us to positioning the component. Because maybe for the real case, the component could be anywhere. So we have to let the system know where is the component first. So for this, we choose this part as a golden sample, and we change the angle. So no matter the component rotate or we can all check the positions. And then right now we go to the run mode. So you can see no matter how we move the component, the system will send the X, Y, and angle information to the system. And next step, we have to know the target, the quality checking part. So in this case, in the beginning of the video, there's a three screw, the metal screw. One part is missing. So we use the function is like an area function to check you can see right now it's become white and black. So we want to check the white part because it's a metal. We use the light to reflect to make it become white. So we need to know the white part. So after this, we have to combine with the positioning the shift function. So let the system know no matter the component move to where, they will still target the screw, the metal screw. So we go to the run mode again, and you can see the area. There's a green circle. If you see, will follow the component to move. So we finished the first one, and for the else, the two more, actually the same thing. So we just use the function copy and paste to quickly finish the job. This is for setting the third one. And then we go to the run mode again. You can see there's 3 green circles around the metal screw. And here's all the output result. So if we want to check the details, like the value of the white part, the white pixels, we just output the user result to check the value. You can see the value. Actually, the value is the pixel number of the white part. And now we change another one, the defect one. So you could see the I1103. The value is very low because system cannot detect the metal screw. And if we want to give it result like OK or NG, we will set some limitation to do some judgment to let the system know below what value is OK or below what value is not OK. Okay, so after the parameter settings, we could switch to the run mode again to check the value output. So you can see right now the third one actually become red because we set the limitation. So it becomes red. And then we change to another one, the OK one you see is all green. Green means it's okay. So what if you want to set the judgment as OK or NG? So we have to do some logic at the judgment area. So first one we give them some input, and here's a logic and or basic one, the logic. So we have to. So in this case, we do the AND logic. So you can see. No, it show the result. I think it's very easy to let user know how to do the application. I think the interface is very friendly. So this is the first application. So next one, I would like to see the cup inspections. Paper cup inspections by the DMV1000. Okay, so this is the application environment. For example, it's in the conveyor production line, and we use the camera to check no matter it's a defect on the bottom or defect on the gap of the bottom or in the bodies or in the gap of the bodies or on the top. So we can all detect this kind of failures. So back to the system, we have to start a new project. Also, we could save the program into the SD card or in the controller itself. And then we change the continuous image to adjust if the camera need to be adjusted. And then we put the cup here. And you can see actually it's many dot inside the cup. So this is the target we have to detect. So here's some adjustment. If the too dark or too light for your reference, and then we capture a picture as a sample for the next move. And here you can see in the applications, we do have these 4 functions, and just the insert cup function. And then we select the image. And here's some filters. We use the shade filters. And you can see right now it's become like base. And also there's some judgment, like the noise level. So the filter size. So this is all dependent on you to adjust to get what you want, the best result. And then we go to the parameters to target the bottom of the. Okay, you can see the system automatically find the gap of the bottom, and then we go to check the top. we have to keep the top edge between you see the two circuit. So the system automatically get the top, and then we have to check the line. So here's the detail adjustment. You can see here's some threshold for you to, if the target not sure, maybe you can change the threshold to make it more obvious. And then we check the cup of the bottom. You can see actually right now is we already get the defect part. So all these values is for you to judge. And for the top of the cup, we have to spend a little more on this. So we go to the next part, is the mask. We have to identify the inner circle and the outer circle. So here we do some change so that you see more clearly about the result. So all the purpose is to make the result, so the result you want becomes more highlight the result you want. So I think right now the outer circle is finished, and then we come to the inner circle. Okay. So until now, all the settings is finished, and then we go to the run mode to check. So we manually trigger it. So this is all the defect part identified from the system. So we move the cap and to check the defect. Okay, so this is the second one, the paper cup inspection. And for the last one is the calibration of the robot and the vision DMV by DMV3000. So here's the environment, the architecture. You can see here's the camera robot, and on the top we have one camera. And there's some whippers, like this arm, and from the bottom, there's a black light to, and then we put some component into it. And so the purpose is we use the camera to let the robot know where's the component, and then we move it. The robot will automatically go to that. So this is the view of the view, and here's some tolerance. So back to the project, we start a new one. And we do some communication settings. This is we already linked with the robot controller by the Ethernet cables. And then we choose the auto calibration functions. So actually, this page we link with the robot. And when we do the servo on, we will control the robot to move. Okay. Like move. We are trying to move the gripper to the center of the FOV. Okay. Then, since it looks a little dark, so we change the shutter speed, give it more light, make it become more clear. And then we take a picture as a sample. All right. Okay, and then we go to the functions, the ship functions. First, we have to target one position. Like for this case, we use this is the target. We use the hole as a target position. And then we give it the tolerance for the run angles. And next step is locate. The default settings is okay. And this is the training process. We get the position from the robot first. Here we have many type of the training point. So in this case, we select the 36 point for the training. And then we give some offset and then get the robot calibration coordinate and then start the training. So you could see the robot will automatically training by himself. There's a 36 point. So the robot may move like X, Y angles to move it to do the training. So you may have the question, why the system has to do the training like this? So for this part, we have to back to the coordinate. You know, actually for the robot, it has its own self, the coordinate for the robot. But for the vision, because they are not the same mechanicals. So for the vision system, it also has the coordinate from the vision. So after the vision take a photo, how to inform the robot to go to the coordinate from the robot. So we have to merge the two coordinates into one coordinate. So this is the why we do the training. We have to merge the two things together, or let the vision to transfer the vision coordinate to robot coordinate. Okay, so now the training is all set, all finished. And next one, we go to the type of the applications that we can place. And now we get the positions from the robot. This is the positions from the robot. So this is like a start point. So we will record the vision, the coordinate, and the robot coordinate, and combine with the training. So the vision will know how to transfer the vision coordinate to the robot coordinate. And then we move move back the robot. So for the calibration is all finished. And next part, we have to inform the system where is the target object. So same, we use the shape functions. We use the shape function to inform the system where is the current data position, and also the angles. And also we give the tolerance of the angle. So if it rotates, the system will get the angle too. And after that, we have to output the value to the robot to let the robot know where is the what is the target coordinate now for the target component. And we can do the we convert the coordinate automatically from the vision system to the robot system. And in this case, actually, we use the modbus parts to link with the robot controller from the vision. But at the beginning, actually, we use a laptop to control the system. So that's why it's a mobile IPC. So now everything is settled. So we go to the next part. We go to the run mode to check. So now it's already in the run mode, and it's continuous triggers. And we give the robot a program to let it first detect the coordinate and then move it, and then go back and delay for like 3 or 5 seconds, and then detect and then move again. So you can see we move and output the signal, output the values to the robot, and robot will come here. And also include the angles. You will see actually the robot will adjust the angles from the grippers. You can see it change the positions. So every time we'll fit the component. Back to the starter, the tolerance between the component and the gripper is only 0.2 millimeters. So this is the accuracy. Okay. More than 1 hour. So I took a long time. So that's all for the training. So any questions for the product, or for the demonstration, or for the successful case? You raise your hand. And I saw the questions. Do you provide the light? And for today's, even the video, even the material, training material, and even the successful case, actually we have a lot. I just highlight some of them. And then you can scan the QR code here. And we're back to the page about this one. Delta industrial automation. I put the machine vision to the control part. And then, okay, you can see this is the machine vision portion. And this is all the video. And I also have others and reference. And this is a successful case application sharing. I could see there's more than 50 successful cases for your reference. Same thing in my presentation.